Most people think AI research tools are just fancy search engines. You ask a question, it searches the web, gives you some links, maybe summarize a few articles. The conventional wisdom is that AI agents work best when they are simple, focused, and doing one task at a time. Keep it linear, keep it predictable. But here is what Anthropic discovered that changes everything. The most powerful AI research doesn't come from one super smart agent. It comes from multiple AI agents working together like a coordinate research team. Each with their own specialties, each exploring different angles together, then combining their findings into insights no single agent could achieve. How do I know this works? Anthropic multi-agent system outperformed their best single AI agents by over 90% on complex research tasks. When tasked with finding board members of all information technology companies in the S&P 500, the multi-agent system succeeded while the single agent failed completely. Users are reporting that this system saves them days of work and uncovers research connections they never would have found alone. In the next few minutes, I'm going to break down exactly how Anthropic built this revolutionary multi-agent research system. You will discover the three core principles that make it work, the biggest engineering challenges they had to overcome, and why this approach is about to transform how we think about AI automation. Let's dive in. Traditional AI systems follow a linear path: input, process, output. But research isn't linear. When humans research complex topics, we naturally branch out, follow leads, pivot based on discoveries, and synthesize information from multiple sources. Anthropic realized they needed to mirror this human behavior. Their solution, an orchestrator worker pattern, where a lead agent acts like a research director, breaking down complex queries into specialized tasks and delegating them to sub-agents that work in parallel. Here is how it works in practice. When you ask about AI agent company in 2025, the lead agent doesn't just search sequentially. Instead, it creates specialized sub-agents. One focuses on established players, another on startups, another on market analysis. Each sub-agent has its own context window and tools, exploring different aspects simultaneously before reporting back. This matters because it solves the fundamental limitation of single-agent systems. As Anthropic discovered, individual intelligence has limits, but collective intelligence scales exponentially. Just like human societies became exponentially more capable through collaboration, AI agents achieve far more working together than alone. But here is where it gets really interesting. This parallel approach revealed something surprising about what actually drives AI performance. Anthropic made a shocking discovery while analyzing their system's performance. In their evaluation of browsing agents, three factors explain 95% of performance variance: token usage, number of tool calls, and model choice. The biggest factor wasn't the AI model's intelligence. It was how many tokens the system could spend on the problem. This insight revolutionized their architecture. Multi-agent systems effectively scale token usage by distributing work across agents with separate context windows. Think of it like having multiple researchers with unlimited notepads instead of one researcher with limited space. For example, when researching semiconductor export restrictions, instead of one agent hitting context limits after analyzing a few sources, multiple sub-agents can each analyze different aspects: policy detail, company impacts, market analysis, using their full context capacity. This discovery validates a counterintuitive truth. Sometimes the solution isn't smarter AI. It's more AI working together efficiently. Anthropic found that upgrading to Claude Sonnet 4 provided larger performance gain than doubling the token budget on older models. But the multi-agent architecture lets them leverage this efficiency at scale. Now, this token breakthrough was crucial, but it created an entirely new challenge that most AI companies haven't figured out how to solve. Here is the dirty secret about multi-agent systems. They are incredibly hard to control. Anthropic early agents made embarrassing mistakes, spawning 50 sub-agents for simple queries, searching endlessly for non-existent sources, and agents distracting each other with excessive updates. The coordination complexity grows exponentially with each additional agent. Anthropic solves this through revolutionary prompt engineering techniques. First, they build simulation using their console to watch agents work step by step, revealing failure modes immediately. Second, they taught the orchestrator detailed delegation. Each sub-agent gets an objective, output format, tool guidance, and clear boundaries. Third, they embedded scaling rules directly in prompt. Simple fact-finding gets one agent with 3 to 10 tool calls. Complex research might use more than 10 sub-agents with clearly divided responsibilities. For example, instead of telling a sub-agent to research the semiconductor shortage, they learn to give specific instruction. This matters because it reveals the real challenge in AI automation isn't building smart agents. It's building agents that can work together reliably. The breakthrough came from treating prompt engineering not as instruction for individual agents, but as frameworks for collaboration. But even with perfect coordination, there was one more obstacle that nearly killed their entire project. Moving from prototype to production almost broke everything. In traditional software, bugs break features. In multi-agent systems, minor changes cascade into completely different behaviors. Agents are stateful, running for extended periods while maintaining context across many tool calls, which mean errors compound dramatically. Anthropic developed 3 critical solutions. First, they build systems that resume from interruption points rather than restarting from scratch, because restarts are expensive and frustrating for users. Second, they use the model's intelligence for graceful error handling, letting agents know when tools are failing so that they can adapt. Third, they implemented rainbow deployment to avoid disrupting running agents during updates. They also revolutionized debugging through full production tracing. When user reported agents not finding obvious information, the traces revealed the real problem: bad search queries, poor source selection, or tool failures. This observability helped them fix issues systematically while maintaining user privacy. This production engineering reveals a fundamental truth about AI systems. The gap between prototype and production is often wider than anticipated. The compound nature of errors in agent systems mean minor issues for traditional software can completely derail agents. This engineering breakthrough enables something that is already transforming how people work. The results speak for themselves. Anthropic data show that multi-agent research systems excel especially at breadth-first queries involving multiple independent directions. Users report finding business opportunities they hadn't considered, navigating complex healthcare options, resolving technical bugs, and uncovering research connections they wouldn't have found alone. The system works because it mirrors expert human research behavior. Start broad, then narrow focus. Agents begin with short, broad queries to explore the landscape before drilling into specifics. They use parallel tool calling, both spinning up 3 to 5 sub-agents simultaneously and having each sub-agent use multiple tools in parallel. This parallelization cuts research time by up to 90% for complex queries. Real usage data show people are using the system for developing software across specialized domains, optimizing professional content, developing business strategies, academic research, and verifying information about organization. This performance revolution matters because it's not just faster research. It's fundamentally different research. The multi-agent approach finds connection and insight that single-agent systems miss entirely. It is the difference between having one really smart researcher and having an entire research team with complementary expertise. What Anthropic achieved with their multi-agent research system isn't just a technical breakthrough. It's a glimpse into the future of AI automation. They proved that the path to more capable AI isn't necessarily smarter individual agents, but smarter collaboration between agents. The key insights that made this possible, embracing the orchestrator worker pattern that mirror human research teams, understanding that token usage drives performance more than model intelligence alone, solving coordination complexity through detailed prompt engineering frameworks, and building production systems that handle the compound nature of agent error. But perhaps most importantly, they demonstrated that multi-agent systems can operate reliably at scale when built with careful engineering, comprehensive testing, and deep understanding of current AI capabilities. This is just the beginning. As these systems continue to evolve, we are looking at a future where complex research tasks that currently take human days or weeks can be completed in minutes, with insights and connections that no individual human or AI could discover alone. The question isn't whether multi-agent AI systems will transform how we work. The question is how quickly you will adapt to this new reality where AI agents collaborate as seamlessly as the best human teams. Thank you for watching this video. If you are a developer or an entrepreneur who wants to stay ahead on AI agents, LLMs, and automation breakthrough, subscribe to my newsletter.